Welcome everybody. This is introduction to Raycasting in Unity. So if you're here for that, thank you. If you're here for that, you're in the right place. And if you're not, stick around anyway, because we're going to have a great time. I'm going to go through some housekeeping notes. Part one is going to be covering a little bit about vectors. So that's going to unfortunately be a little bit dry, but it will be important for what we're doing later. Just one more time for those of you who are viewing this online or who came late, bit.ly/Raycasting, and yeah, I got Raycasting. It's crazy. We'll take you to the place that this workshop is following. Okay, so the structure of this workshop is going to be a little bit of vectors. Fortunately, Unity does all of the heavy maths for us, so this isn't going to be a high school vector class. But what I hope to do is instill a little bit of a sense of the intuition that you need for vectors. Then next we're going to go into the foundations of Raycasting, where we'll open Unity and write a short little script to just get a sense of what Raycasting is and does. And then thirdly, which is a little bit more open-ended for Unity, come on in. The applications where we will try to make something cool using Raycasting. So, to start, vectors. Or at least, why are we here, Raycasting? Raycasting is the process of pointing a line in a direction and figuring out what we hit. So Raycasting is not specific to Unity. We can do it in Life, in JavaScript, in Unreal, whatever you want. My version in Life would be pointing that way and saying, oh, look, there's a whiteboard over there. It's a very simple process to explain. To do it, we need to know vectors. And like I said, most of the heavy maths is done, so this is just kind of like intuition about what vectors are. There's a couple of different ways to think about vectors depending on who you are. If you ask a computer scientist, they're going to tell you something different from an artist or a game designer. From my perspective, at least, that's what I'm here to do, is share what I understand. A vector is a line with a direction. So all of that stuff that you hear about origins and magnitudes and all of that, that's like affiliate to vectors, and we're going to go into those. But in general, a vector is a single line with like a polarity, a direction. In general, I've encountered vectors in two predominant ways. One is to represent a position. So this is when you're thinking, like anyone who's used P5 before, on the canvas, when you say 200 pixels across and 300 pixels down, that's a vector. That's a representation of 200x and 300y. So the way that I think about the position vector is a specific there. You are pointing to a specific location. And that requires the idea of an origin. Like, what's the origin of this vector? It could be 0, 0, in which case the position you're pointing to is just the position in x and y. Or it could be in addition to another position, like a relative position. In terms of direction, direction doesn't have an origin, so it doesn't really matter where your vector is. Direction is more of a kind of pointing in an infinite direction and saying it's over there, that way. So, I'm gonna try use this for a second and expose how terrible of an artist I am. So if this is our canvas. A position vector would be there, and the vector to represent it would be this line with an arrow, and that could be something like 3 along y and 2 along x. But a direction vector doesn't really matter where it is. All it's doing is saying, hey, point that way. Does that make sense? Any questions so far?
Where were you when I had math class?
Right. I mean, the important thing to kind of note here is that they're both the same representation. In Unity, both of those concepts are expressed with the type vector. And there's vector 2 if you go into 2D graphics and stuff, but the one, how's that for size? Can people read that? Let me see if I can. There we go, that's better. So I don't want to confuse you further by distinguishing between position and direction vectors. They're just two ways of thinking about the same thing. There's only one vector 3, right? But you can use it as a position or as a direction or later on as rotation and things like that. So in this case, my vector equals new vector 3 3, 2, 1. Don't worry about following at this point. We'll jump into Unity later. I'm just kind of preparing you for the syntax. In this case, 3 is 3 along the x, 2 is 2 along y, and 1 is 1 along z. Right. One of the common terms that you'll hear when dealing with vectors is magnitude. Magnitude is essentially the length of the vector, the length of the line that we're dealing with. So there's some funky maths that we can use to figure out. It's like you might have heard Pythagoras' theorem, where we square this side and then we square that side, add them together, and then we found the square of that side, and that's, ooh, look at that. And that's one way of figuring out. We don't have to do that. Unity handles that. All we have to do is say, like we could say float mag equals my vector dot magnitude. So the intuition is that magnitude is the length of the line. Another term that comes up a lot when using vectors is normalizing. Normalizing is the process of taking a vector and squishing it down or stretching it out so that its magnitude is 1. This one could be a little bit more complex to kind of get an intuition for, but it comes up a lot, especially when using direction, so I'll cover it, or at least I'll do my best to cover it. Go away, go away, go away. Okay. This is the first time I'm using this, so please bear with me. So a term that comes up a lot when considering normalizing is the idea of a unit circle. A unit circle is just a circle that has a radius of 1. This is going to be terrible, but I'm going to try to draw a unit circle. Pretend that's a unit, and pretend that's a circle. That just means that the radius of the circle over here is equal to 1. And the radius of the circle over here, I mean, it's a circle, so the radius is always 1. And any normalized vector is a vector that will fit in this circle. So that's a normalized vector. That's a normalized vector. Let's use green for this. This is not a normalized vector. The process of normalizing this vector is taking that and squishing it down so that it points along the same line, but its length is 1. Right? If this is a little bit confusing, don't worry. We'll get back into it when we go into applications. I just want to introduce you to this term normalizing. Yeah. Of a normalized vector, yes. Yeah. The magnitude is 1 exactly. Yeah, so one thing to note, which hopefully I'll delve into a little bit more later, but this is very useful when thinking about direction. I won't go into the super nitty-gritty details about why just yet, but an application of where you would use a normalized vector, thinking about direction, is if you took a triangle, let's say you have this triangle. Oh, that's terrible. If you had a triangle that was like an isosceles triangle, equals on all sides, and you said in Unity, okay, you're pointing this way, but I want you instead to point this way. If you use a non-normalized vector, so like a really long vector, there's a chance that your triangle could end up looking all squished out like that. I won't yet tell you why, because hopefully we'll get into that later. Actually, I don't think we will, but the consequence of not using normalized vectors is squashing or stretching your objects. So it's safe to use a normalized vector when you say, hey, point that way. You're using a kind of like pure direction. That's the way I think about it, at least. If you have like a physics background, feel free to throw up on me. Because this is not like accurate. This is an intuition. Why is that red? What are you shouting at me about? It doesn't matter. Okay, so that's normalizing, which is a verb, a doing word. It's active. Confusingly, normals are different. So this is where things get a little bit weird. A normal is a vector that points perpendicular to a surface or line. So this pad over here is a surface. The normal of this surface would point either out this way or this way, kind of like directly 90 degrees out from the surface. The direction of that is important when doing things like physics calculations, but for now it's not super important for us to know. It's just important to know that you could have a normal of a 2D line, in which case it would look kind of like these guys are looking over here, or a 3D surface or plane, in which case it would be a 3D vector pointing out of it. Does that make sense? Cool. One thing that we'll be doing later is if you've got a bumpy surface, you can point a ray into it, that's what we're here to do, and figure out like what's perpendicular to that surface. So you could put like a sheep or something on that hill standing on the surface correctly, not like pointing in the world up. Great. Okay, that's the end of the SuperDry vector introduction. Does anyone have any questions at the end of that? Fantastic. The link of this page is right over there. It's bit.ly/raycasting. No worries. You can also find it by visiting my blog, which is called Generally Playful. Okay, now that we have a sense of vectors, let us apply them. Okay, so when you're casting an array, you're pointing a line in a direction and asking what did it hit. You can think of this process in 3 kind of steps. What is the ray? Like which direction are you pointing, and what are you? How far are you pointing it? So the raycasting is the question. Given this ray and the scene that you've created, does it hit anything? And you can also ask, if so, what does it hit? So the 3 general components that we're going to build in this section are the ray that you want to cast, the question, does it hit anything, and if so, what? And then the answer, what do you do with that information? Something that's important to know as we jump into Unity is that raycasting is physics-based. So Unity has like 2 different engines that run at the same time. One is the rendering engine, where you see all of the objects in your scene, you see all of your little people running around, or the game objects, all the meshes, the geometry. And then concurrent with that is the physics engine. This runs on a parallel thread, and they kind of are separate, and occasionally they talk. This means that if you just have a sphere that is just a mesh, and you cast a ray to it, it's not going to see it. Your object has to have a collider on it. So the primitive colliders in Unity are the box colliders, the sphere colliders, the capsule colliders. And you can also create your own mesh and add a collider there. But you need to have a collider for the raycasting to see your object. It's a laser beam. Yeah, it's a single line that goes in one way. The idea of a ray goes infinitely, but when we raycast, we can set a limit on it. For a ray to bounce, you would have to like code that in. You'd have to say, okay, hit that object and bounce off it, then hit the next object and bounce off it. By default, it doesn't do that. It's just kind of pointing in a direction. And the way we're going to do it today, the first thing that it hits, it like says, I hit something. There are ways where you can kind of make it go through other things, but we're not going to cover that today. What's up? Fantastic. So let's construct a ray. Go ahead and open Unity. Create a new scene or a new project, a new scene. If anyone has trouble doing that, please let me know. I'll come around. Yeah, we'll get to that. As people are opening, my screen might look different to yours. This is the way that I like to set up my Unity window. You are welcome to use the default or whatever window works for you. If you want yours to be like mine, which I kind of I like because you can see the scene and the game view at the same time, and you have your inspector in the corner. This is really frustrating. The screen went black again. Right, if you want your window like mine, you could go into Window, Layouts, 2x3. But yeah, if you go 2x3 and then move your, you should see something like this. You can move your project folder underneath your hierarchy. Unity windows are infinitely resizable, which is nice. Let's go ahead and add in a new scene, add a cube and a sphere. Okay, and I'm going to drag the sphere along the Z axis, which is the blue axis, just a little bit away from the cube. Cool. So we're going to create a raycasting script on the cube that's going to cast a ray out from the cube and see what it hits. So there's a couple of different ways you can add scripts. I'm just going to select my cube, go add component, and then type the script name that I want to create. I'm just going to call this a, I think I already have simple raycaster. Yeah, so I'm going to call this, I'll call it, you should probably call it simple raycaster, but I'm just going to call it raycaster. Oops. Raycaster. Oh, and you might have to navigate down to new script and create an add. And once you've done that, double click on the name, and you might have to wait for Visual Studio to open up. If anyone is having any problems, this is a really good time to let me know. Otherwise, I'm just going to continue going forward. Fantastic. This is readable? People in the back? This is readable? Fantastic. Okay, so I'm going to get rid of the start function because I don't need it. Everything that I'm going to do is an update. And the first thing that we need to do is create an array. Creating an array is really simple. Array, going back to our vector talk earlier, is a two vector component because it has a position and it has a direction. So we need to tell it what vector the position is and also what vector the direction is. And the way that we do that is we say type ray. So the ray has a special type in Unity. I'm just going to call it array. So this is one of those cases where we have repeated names and it's kind of confusing unless you get the hang of until you get the hang of how things work in Unity. You could possibly call it myRay, absolutely, yes, if you want to avoid some of this confusion. And just to be explicit, the type ray has a capital R, and then the variable name ray, myRay, has a lowercase starting at. So ray, myRay equals new ray. So this is just a syntax. Excellent, wonderful. Can everybody see that? Sorry, Kara. It kind of sucks for you. Okay, so we've got, I'll go through this for the sake of people who might be a little bit newer to Unity syntax. What we're doing here is we're saying create a new variable called myRay of type ray, right? And the way it has to be type first, then variable, equals new, and new is the keyword that tells Unity that it's going to be a new one. You're not rewriting a previous variable or overwriting anything. And then we'll say ray, then you tell it what you're creating. So you have to be kind of explicit. You're saying, I'm creating a type, I'm creating an object of this type, and it's going to be an object of this type. It's just kind of what we have to deal with. And Ray, if you are using Visual Studio, this little drop-down menu is your best friend. And I think they do it in MonoDevelop as well, if that's still around. Because this will tell you what new Ray expects. And in this case, sometimes you have to just retype it. Sometimes you have to retype the whole thing. And in this case, you can either create an empty ray, which doesn't have anything, or if you click the little down arrow, it tells you it wants an origin and a direction. So I know that I need to put in either nothing or two vectors. And in this case, it's the origin. So the origin of the ray that I'm casting out from my cube, what's a good place to put that? Any ideas? What's that? The location, yeah. So what Dylan was saying is we could say vector 3.0, which is like nothing. It's a vector in the middle of the scene. But the problem is if we move our cube around, then that will continue being at the center of the scene. So the other way we can do this is say transform.position. So that's one vector. And the transform.position, for anybody who's new to this, every single game object in Unity has this transform component. So if you have something in your scene, it has a position. Sometimes if you're not using, if it's not rendering, it's going to be in the center of your scene and it doesn't really matter. But every single object has a transform which you can access. So in this case, we've got a cube and we want to access the transform. And the transform, the position component of the transform component. Does that make sense? Fantastic. So that's going to be the position of our array, and what do we want the direction of our array to be? Well, so we could say towards the sphere, but that would involve a little bit of maths about thinking which way the sphere is. What I'm trying to go for here is I want the ray to kind of point out of this edge of the cube, so along this blue line, the z-axis, no matter which way the cube is rotating. And the shorthand for us to do that is transform.forward. And that is a vector. Transform.forward is a vector that doesn't exist unless you ask for it. And that is the pointing along the z-axis of the object. You can also do transform. I think it's right. Just right and up as well. So that's a really quick and easy way to say, hey, which way am I facing? Or which way is up? Which is both really helpful and useful things. In our case, we want to be facing forward, and forward is along this z-axis. And now I have my ray. Fantastic. Okay, so if we run this, unless something has gone terribly wrong, it should run. That works. I have no errors. Wonderful. I can still move my cube around in the scene, but we're not actually seeing anything, right? This is kind of useless to us because you're creating an array and not doing anything with it. So very quickly, we're going to debug. Who here has used the debug.log tool before in Unity? Okay, so debug.log is kind of like saying console log if you've used P5 or JavaScript before, or print in Python. It's just a way of getting information. Log gives us the specific text information of things in our scene, but we can also debug other stuff. In my case, again, just using Visual Studio as our best friend, debug dot, you'll get a list over here of things that come after debug dot. So in our case, what I want to do is I have a ray and I want to draw it. So I'm going to say debug dot draw ray, and if we look at the stuff that needs, it needs a start. Actually, let's just go draw ray. It needs a start and a direction. It needs a start, a direction, and a color. It needs a start, direction, color, and duration, or a start, direction, and depth test. Okay, I don't need any of that. All I need is the start and the duration. So I'm going to say, just so that we can get a hang of using this ray object, myRay.origin, which is the start of the ray, and then myRay.direction. Everyone good so far? So now if we go into Unity and press the play button, in our scene view, so one thing to note is this is not going to come up in the game view. This is only going to come up in the scene view. This is where our debug information happens. We've now got this little white arrow or line that's pointing out of our cube. All right, so that's just a way for us to know that our array is working. This is like a debugging tool, which is why it's debug.drawArray. So if you're ever drawing an array and you don't know which way it's pointing, this is a good way of finding that out. All right. So just to go over the big picture again, we've now created the ray that we want to use to cast our Raycast. Next, we're going to pose the question, does this ray hit anything, and if so, what? As a kind of, the link is in here somewhere, but kind of foreshadowing what we're going to do, this is just a specific quirk of Unity. We have to know beforehand what the information is going to be. So we have to set up an empty object to take in the information from our hit. And in Unity, this object is called a Raycast hit. So just like we created ray, my ray, we're going to create a Raycast hit, and we'll call it my hit. But we're not going to make it new anything. We're just going to say, hey, this exists. In the future, we're going to populate it with information. Well, I see some confused looks. Does anybody require some further clarification? Okay, but we'll continue creating this. So we've got a ray, and the ray actually has stuff in it, and we've got this general idea of a hit, and the hit has nothing in it. So now we're going to actually ask the question, like, we're going to command the ray to go out into the scene and see if it hits anything. And the way that we do that is you could either go to, at the bottom of page 2 is further resources, the documentation, or you could, I mean, I do this all the time, just type in Raycast Unity. And with Google as your best friend, it's usually the first link that comes up, scripting API physics.raycast. This gives you a bunch of different ways to interact with the raycasting mechanism of Unity. The first result is kind of scary because it involves things like layer mask, which is scary, and you know that's kind of confusing when all you're trying to do is shoot a ray out and see what it hits. So if you scroll down a little bit further, you get something that's a bit more bearable, which is this idea of if physics.raycast transform position forward and then 10. This line, actually even just this section of the line, this if physics.raycast is what we're looking for. So I'm going to type in my scene, if, and then put in brackets, physics. So like I said, raycasting is a physics property, so we're going to say physics.raycast. Okay, and once we open these brackets, you'll see again that we have a little option here. And there's 16 possible things that we could do with this. So that's a lot. And it's good to know what they are and what you kind of want to do with it. The first is you just give it a ray. So this is going to say, when you shoot a ray, it's going to say, yes, you hit something, or no, you didn't. True or false. It's a bool. That's what it returns. That's why we're putting this in this if statement. The next thing that we could do is put in a ray and a max distance. So that's pretty neat because we can say, hey, is anything in front of me up to like 10 meters? So in some way, this is like a kind of distance sensor. If we're using one of those like ultrasonic distance sensors, you can use a ray cast as that. Is there anything in front of this up to 10 meters? And then if we scroll down a little bit more, we've got ray and then out raycast hit info. This is where things might get freaky because out is new. Out is a new term that is very scary for some people. But all out, what's that? Yeah. So you can think of out a little bit like return. The problem is that this physics.raycast is a Boolean function. So it's always going to return either true or false. But there's no way for it to return more information than that. It can't return a bool and a vector, or a bool and information. So out is C#. This is a fundamental property of C#, the language. When you say something like, so I'm just going to put in my ray here, and then when you say something is an out variable, or an out parameter, sorry, it's basically saying, I'm going to put this variable in to this function, but this function is going to change it somehow, and then I want to access it afterwards. So, as Louisa was saying, this is basically a way of returning more information than the function allows. So you can think of it as, you've declared this empty myHit object. Once you call this function, this object isn't going to be empty anymore. It's going to have some stuff in it. Right? How are people following? Is that, you have a question? Yes, thank you. That is a very good point. I don't know if you had a question. Okay. So there's a couple more things that we can do here. If anybody is interested in having more information dumped on them, all of these extra things that are happening over here in these drop-down menus, or these scrolling menus, these are called overloads. So the function has a specific version of it that takes in 0 parameters or 1 parameter, and then when you add more parameters, it's overloading that function. I don't say that to confuse you more. I say that so in the future, if you see the term overload, because the first time I saw it, I was like, what? I've never heard this before in my life. An overload just means like you're adding more things to the function. C#, unlike JavaScript, which some of you may be familiar with, you can't just put anything in functions. You have to be very specific. So overloading is a way of saying this function can take multiple different versions of things. So we could also add a maximum distance here, but for now, I'm not going to add a maximum distance. These are the only two things that I'm putting in my raycast. My ray and my hit. Yeah, so this ray is going to go on forever, and if it doesn't hit anything, this if statement will return false. If it does hit something, it's going to return true, and importantly, we can access what it hit using my hit. One of the colliders. So we'll get into specifically like what type of information we can get out, but if we go, where's my sphere? So in this case, my sphere has a component called a sphere collider. The hit object that we get back, we can call. Let's do this. Let's debug.log hit. Sorry, it's my hit dot collider. So if we go my hit and then dot, we'll see a bunch of things that we can get out of this. These things are that information that you were talking about, right? So there's things like the point, the normal. We heard normals earlier. We know what a normal is. We can scroll all the way through this. And collider, for example. So if I choose my hit.collider, this object that we now have access to is this component, the sphere collider component of this game object. Does that begin to make sense? Maybe one thing that will help kind of set the scene here is Unity's, okay, wow, stepping back big picture, but Unity, everything that we're doing is in the game object component system, which means that, as I said earlier, everything in your scene has a transform because everything in your scene is a game object, right? And when we add new game objects, we've got the option to add empties, and then a cube, a sphere. The thing to know is these are all basically empties, just with more stuff in them. So when we're adding a cube, we're adding, where are we? Game object, 3D cube, cube. When we add a cube, it's an empty object called cube with a cube mesh on it, a mesh renderer, a box collider, and a material. You could take an empty and populate it with that type of stuff, and it would be exactly the same thing. Does that make sense? Okay, so that part is cool. Which means that when you're accessing things, you're either accessing game objects or components. So in this case, when we say myHit.collider, we're saying that component collider, right? So one of the outcomes of this is we could also say, hey, take that component and give me, using dot, the game object of that component. And that game object has other components in it. So we could be really obnoxious, please don't do this ever, and say, hey, get that collider, get the game object of that collider, and then get that collider of that game object. But don't do that. What we could do is say .name, though. I actually don't think the collider.gameObject.collider would work, but oh, you'd have to go dot get component and then get the collider. Oh my god, I want to throw up. Let's not do that. So what I'm going to do is I'm going to say this is it's a little bit of a clunky. There's lots of dots, but it's my hit dot collider dot game object dot name. And that might seem like a lot of wall of text until you break it down into what it is, right? It's the hit component that we have, which stores a lot of information, the collider component that we hit, the game object that has that collider as part of it, and then the name of that game object. In our case, the name right now is sphere, but we could name it something useful like hit me. No, that's terrible. Sphere to hit, right? And I'm just going to rename the cube Raycaster. All right, everyone following this notion of hit.collider.gameObject.name? Okay. So if I run this, what do you expect will happen? I think let's find out. Oh, you know what we can do, just because I anticipate a little bit of a problem. So this is a Boolean. It returns true or false. This code here is running in the case of true, right? Just to make it a little bit easier on ourselves, I'm also going to add an else. So in the case that it's not, yeah, let's debug a quick message to ourselves to say no hit. And if I wanted to be really good, which I strongly suggest that you try to do, we could add a string here saying hit with the name that we hit, just to be explicit about what's happening. Because I've done this before where I just like log the thing that I'm interested in, and once you've done that 30 times, you kind of lose track of what object you're referring to. All right. How are people doing? Thumbs up, thumbs down. Excellent. So let's see. If we run this, we've now got hit sphere to hit. Fantastic. So we're hitting that sphere. And then if I rotate my cube a little bit, there's now no hit because it's facing away. That's raycasting. Thanks for coming to my tip. Let's delve a little bit further into this. All we're doing at this point is debugging.logging stuff, which will hopefully help you get an intuition of what information we can get from a hit, from the hit object. So one thing that we can do is now cast array out as we did before, but if we hit something, extend that ray to, extend the line that we're drawing to be at the object. That was a terrible way of describing it. I think with my hands, so let's just go in and code this. As we had, did I delete my debug.drawArray from earlier? I must have. How sad. Never mind. We're going to debug.draw. There's two ways that we can do this. We can draw line or draw array. Which one should I choose? It really doesn't matter. I just have decision anxiety. Draw array. Fantastic. So what draw array wants is a what does it want? Oh, yeah. It wants a start and a direction. So the start is going to be the same as before, the transform for myRay dot origin. But now the direction is going to be not just the direction of my ray, but the direction of my ray extended out to the hit point. And one way we could do that is try to figure out the distance between my object and the sphere and then do some subtraction maths there. But a variable, if we go to my hit and press dot, so we can kind of explore the things that we have in my hit. If we go down, where is this? There is a distance. Excellent. So we're going to take the distance and multiply it by my ray dot direction. And I'll explain why we're doing this in a hot second. The reason that we are doing this is, by default, if you remember earlier, we were talking about normalized vectors. We were giving, transform.forward is a normalized vector. So it has a length of 1. When we were drawing the ray, debugging the ray from our cube, you'll notice that it was pretty, there was like a tiny little line extending from the cube, right? That in the Unity units had a unit length of 1, because that vector was a normalized vector. So in this case, what we're doing is we're saying take that normalized vector, which is a direction, so it's of length 1, and multiply it by the distance between me and my hit point. So the distance between... This isn't going to be infinite. It's going to be infinite if there's no hit, but if we hit something, it's going to be the length between me and the distance and the object that we hit. Does that make sense? Look at that. Did I lie to you? So in the case that we don't hit, all we're doing is debugging no hit. We're not actually drawing any lines. What we could do is say debug.drawLine from myray.origin to myray. What do you think we could do here? .direction. So at this point, one thing to note is that in the case that this returns false, we don't have access to my hit, or my hit is nothing, because we don't actually have any hit information. But what we could do is just give it an arbitrary length. We could say like times 100. So this way, when we don't hit anything, the ray is going to extend to infinity. But when we do hit something, the ray is going to then contract. The other way that we can kind of identify the difference here is add a color. So Unity has a color object, which is going to be an RGB value. Color, and it has some preset values for us. So we could say new color and then give it an RGB value, or we could just say color dot red. Let's go with red. And for the one that hits, I'm going to say color dot green. So green is hit, hooray. Red is no hit, boo. So I'll let you all copy that down for a second. It seems like someone has a problem, so I'm going to go over and help them. Yeah, so this is what I just want to note, and I'll actually go over. This is a problem that you might encounter one day while just like, you're like, oh yeah, I know how to code in Unity, and you start coding, and it's like, this is a massive issue, and you don't know why. It happens to everybody, so I'm just going to like put it out there for now. If you've encountered it before, then you'll know what I'm talking about. If I rename this class, I'm like, you know what? I don't like the name Raycaster. I'm going to call it like my Raycaster. Cool. And I save this. Unity is going to throw a fit. It's going to say, I don't know what you're talking about anymore. And I can't add it to any scripts. And if I try to run, things are going to crash. It's because when you rename a class, it doesn't automatically update the name of the file. And for some stupid reason, the file needs to be the same name as the class. So there's two ways that you can problem solve this. One is, once you've renamed a class, go into the file name and rename that file name too. Right? My Raycaster, and then maybe you'll be able to add it to a sphere. Okay, yeah, then you could. The trouble is you might have to go through every reference that you've made to this class and then change it. So the other way of problem solving this is to never rename your classes. Which is kind of the way that I approach things. So that means that when you go into, like, if I wanted to add an object to sphere and I went down here, add component, this is like the moment of truth. This is when you have to choose the name and just stick with it. So this moment of naming is kind of an important one. Yeah, so that's that. Does that answer your question? Does it work now? Fantastic. Right, okay, so somebody asked a question, which is a really good question. How am I getting these autocompletes? Like when I say dot name, how am I getting this type of stuff? This is a very good question because without it, I am not a Unity programmer. Like, this is the thing that saves my life and makes Unity programming bearable. So if that doesn't work for you, I strongly recommend that as soon as you can, you figure out why. I think I've had it before where if you go into Edit and then Preferences, somewhere, oh my goodness, this is terrible because I'm like debugging on the fly. Here we go. In External Tools, there's an external script editor, and fortunately I had a default Visual Studio. But you might have other options here. You might need to open by file extension, so browse and figure out where the files are. Another way that this is sometimes solved is by deleting and reinstalling Unity and Visual Studio, which I know is a little bit annoying, but yeah, I can't debug this for you at the moment because I think there's so many different ways that this could go wrong. But yeah, if you're not getting these autocompletes and these autofills, like that's a huge problem. So I don't want to spend too much time on this, but it seems like a lot of people with new versions of Unity on new Macs are having the problem. So I will investigate that and try figure out why. Okay, so that does throw a little bit of a spanner in the works. I would just say for now, follow the text that I'm writing, and it's going to be a bit of a pain to write out the whole information. Rashida, did you figure out why yours was broken? Excellent. Okay. Let's figure out what's next. Okay, so we've done something with the hit. We've drawn a green line. Oh, actually, I've never actually run this. So in the case that you don't have a weird lines not showing up problem, which I suddenly seem to have. Oh, you know what? I think I've probably just done this incredibly wrong. Yeah, and I entirely blame. No, I don't. No, absolutely not. But so what I want to do is try this a different way. I'm not entirely sure that this draw array is working like I expect it to work. Is that? It works on yours?
Yeah, perfectly.
Oh. Never. Fantastic. Okay. What am I doing wrong then? Does anybody have any ideas what I'm doing wrong? Yeah, so I think that's what I'm going to do now, which is great because it's just showing you a different way of doing things and a different piece of information from my hit that we can choose. So maybe I'll go back and edit all of this out of the online version because that's kind of embarrassing. So I'm not sure if draw array is working as I expect it to, and maybe I have a typo here which is too long to debug. So the other thing that I'm going to do is debug.drawLine. This is very similar to draw array, except instead of saying a start point and then a direction, it asks for a start point and an end point. So we're going to say where I currently am to where the hit is. And the way that we do that is, again, myHit.origin. No, shit, sorry, that's not true. myRay.origin. You should be calling me out for this. Terrible. And then, so the start of this line is the current center of the object that we're casting from. And the end point of the line is going to be my hit dot, this one's really easy, point. So hit dot point is the exact world coordinate position of where you hit the other object. It is a very useful thing. It's probably one of the most useful. I should have started with that. Yeah, hit dot point is the world position of your hit point. I'm also going to color this red. No, green, because it's a hit. Green is good. Read green. And I'm going to do the same thing. So this is where things get a little bit different. Again, so at this point we don't have access to myHit.point. So instead we're going to just cast a line from myRay.origin. So this is the origin of the ray. Plus, so we're taking a position vector and adding another position vector to it. myRay.direction times, we're not going to say myRay.direction, we're going to say transform.forward. Either way, I think it'll do the same thing, but maybe that's what's going wrong in my code. So does anybody feel like passing through this line for me and kind of describing what's going on? I just want to make sure that my sanity hasn't left me. That sounds amazing. Does everybody track that? Thank you. Okay, so I'm not going crazy. Thank you. Okay, let's find out if it works for me. It does not. What the? I think I have the same issue as Louisa. Oh, wait. Okay, I broke the Raycaster script. There we go. I broke the Raycaster script by renaming it. I told you this would happen! Okay, it happens to literally everyone. And this is new. I got a yellow little warning message over here, so I think that's new in Unity, which is great, because it'll kind of help you track down what's going on. Oh my goodness, there we go. Okay. So now we have an array that is red when we're not hitting anything and green when we are hitting something. What's beautiful about this is while we're playing, we can duplicate, which is Control D. I don't want to do that. And the hotkeys that I'm using are W, E, R. So W gives you these little movement arrows, E gives you a rotation, and R gives you scaling. So we can just move this object around a little bit, duplicate it again, move it around, duplicate it, then let's scale some a little bit, move them around. And now we have a nice little scene to test our Raycaster on, and it works on multiple objects, which is great. So the applications of this are already quite numerous. I think this is fundamental to how many stealth games work. This is great for line of sight. If you have a character that is going to jump on you if it sees you or something. Yeah, there's a couple of there's different ways you can do that. Unity has some built-in functions where you can like project a camera and figure out what the camera sees. That's like a little bit more in depth. To do that, like low resolution or on the cheap, you could just create multiple raycasts and send them out. The trick would be figuring out the maths for the code that you want to project. Yes, there are many. Does anyone have any questions after this basic the foundations of raycasting, the structure of creating an array, asking the question, and then doing something with the answer? Excellent. If you are interested in finding more about the depths of raycasting, this documentation is one way to go. Just to give you a very brief overview of the concepts here, layer mask is a way of saying there's different physics layers, so you can have something which is like hard objects in your scene, something which is water in your scene but still needs a collider, something which is the player that should collide with some things and not others. And you can assign a layer to each of those, and a layer will be an int. And layer mask is telling Raycast which layers to ignore. And it involves a little bit of funky bit shifting and stuff, but the documentation kind of gives you a way to walk through that if you're new to it. You also don't technically need to create an array. You can just inline code the position and the direction that you want to do the array. We were just doing array for clarity. And in a hot second, we're going to go through screen point array as well, which is a very useful function. Great, so that link is over there, and now we're going to move on to the applications of raycasting. How is everybody doing? Do we need a 5-minute stretch, or are we good to bound forward? Yeah, absolutely. So, does anybody else have an answer to that? The question was, could we cast a ray not from the center of the object? Yeah, 100%. So the ray requires two things, a start position and a direction. So you could change that start position to anything. You could be casting rays out of people's eyes, out of people's noses, out of, I don't know, ears. All good. You okay? All right, so in these last 35 minutes, we are going to try and speed things up a little bit and deep dive into, or jump right into placing objects in your scene. So the hope here is that we'll get to something like this, where you click and something is added to the scene in the position that you click, and very importantly, lined to the surface that you're clicking. But to get there, there's a couple of different things which need to come together. My hope is that we get this done by 8, but I have a hard out at 8, so if we don't, the resources are here, and I hope they're comprehensive enough. So before we jump into this, we need to create a camera system. Do we? we don't actually need to create a camera system. So who is okay skipping the camera system? Okay, we're skipping the camera system. If you're interested in camera rigs in Unity, read through this. I think it's kind of fun, and I drew some stuff. But we're going to ignore all of that, and we're going to jump straight to creating an interesting floor. So one thing you'll notice about the video that I just showed you is that we did not use a simple plane as the floor. We used a floor which was kind of bumpy. The way that I'm going to do that is just a quick hack, is create game object, 3D object, plane. Right, we've got a plane, and I'm going to rename my plane something useful. I'm going to call it the floor. This is the floor. Sometimes, and I haven't figured out how or why yet, so in the comments, please, if you know the answer to this, let me know. Sometimes when you create things, they will come at position 0, 0, 0, and sometimes when you create them, they will come at a random different position. If they come in at a random different position, that can be problematic for your scene. So I generally, as soon as I add something to the scene, I go up to the transform tab, and there's these 3 little dots right in the corner. If you click those dots and hit reset, it's going to reset all of this to the center of your scene with no rotation and the right scale. Or not the right scale, a 1, 1, 1 scale. That's also a useful thing to do if you've lost your object and you don't know where it is, and it's off 300 units to this side. Okay, I'm then going to make my plane really big. So I'm going to say, let's just do 10 by 10 by 10. So I've got a nice big plane as a floor. This is a good time to, if you are interested in revisiting these scenes later, to save your scene. I've got mine as workshop, and then duplicate it. Where are we? Where's duplicate? Yeah, okay, if you right click, and honestly, duplicate is right there, but I'm just going to say Command D, or Control D for Windows people, Command D for Macs, and then rename it as a different scene. So I'm going to call this sheep placement, because we're going to be placing some sheep. Yeah, that's a good thing to note. The scenes is just a way of distinguishing what's in your scene, but if you change the actual assets, you're changing them across multiple scenes. The other thing to always be aware of in Unity is what scene you are in. And you can tell that by, in your hierarchy window, the scene that you are in is the name at the top of your hierarchy. So if you've just duplicated your scene, you will still be in the previous scene, even though you've duplicated it. So if you want to move into the new scene, go into sheep place, into whatever you called it. All right. Everything makes sense? Everyone following? Fantastic. So we'll now delete the 2 things that we added earlier. We don't need those raycasters anymore. So all we should have is the main camera, the direction light, and the floor. In my game window, because we're going to be using the game window for this a little bit, I want to make sure that my camera is raised up a little bit. So I'm going to press W to move my camera and move it up along the Y-axis a little bit. Right? It doesn't really matter too much how far I go. And I'm also going to press E. Am I? No, instead of pressing E, I'm going to go into the rotation of my camera. That's this transform window over here. And start dragging X a little bit until my camera points, in general, down. It doesn't matter exactly how far down, but a 45-degree angle seems kind of nice. You have a question?
No.
Oh, fantastic. Does anybody have any questions? Excellent. So as long as my camera is pointing at my plane, that's good enough for now. I'm then going to add some more geometry to my scene. You can do that either by going Game Object, 3D Object, Cube, or right-clicking in your hierarchy, saying 3D Object, Cube. I'm choosing Cube randomly, but feel free to choose whatever you want. Remember to reset it. And one hotkey that you should become really familiar with in Unity is F. F stands for frame, which frames the currently selected object. What's that? It's focus. Oh, okay. I guess it's frame in Blender. No, it's not frame in Blender. In Unreal, that's it. But maybe it's focus there too. Anyway, I'm just going to edit that bit out. F stands for focus, which I knew all along. No, I'll keep that. So with our object selected, all I'm going to do is rotate it a little bit so that it's like at an angle, and then scale it up. And the hotkeys that I'm using for that, once again, are E to rotate, because that makes sense, and then R to scale, because why not? And I'm going to duplicate this a couple of times. Really, this is not about raycasting. This is just setting up a scene. So one thing to note here, I'll just mention it, but we don't have to get too far into it. My axis alignments are currently what's considered local. So this object is being moved along its own X, Y, and Z axis. That's not super helpful to me because I want to move this along the floor. And to move it along the floor, I'd have to like move along Z, then move along X for a little bit, then move along Y, and that's very, very tedious. So to change the axis that you're using, either local or global, you can either press this top button over here, which says local, and change that to global, and you'll see the axes now the axes now match what the world coordinate axes are in the top right-hand corner. Or I think the hotkey is X. X switches between local and global. Okay, so we can move these around, scale them up, rotate them a little bit, and just do this a number of times. Cool. And keep an eye on your camera view. You want to make sure that your objects are inside the camera view. So yeah, the three hotkeys, they're all together in the top right, top left of the keyboard, W-E-R. All right. Okay, I think that's enough time to create an interesting world. What I generally do, and I'm just going to tell you in case you decide that you want to do it too, is once I've created an environment, generally the environment has a lot of game objects in it. So these tend to clutter up my hierarchy. So usually, after creating my world, I'll create an empty object and center it. This is very important, to center it first. And rename this object as ENV or something, environment. Yeah, just make sure that its position, scale, rotation are 0 and its scale is 1. And after I've reset this, the transform, I'll take all of the game objects that form the environment and form the world and just drag them into ENV. So then I can collapse that and forget about it. I never have to worry about that again, unless I want to go in and start adjusting things. So now I'm going to quickly just hide environment, because what I want to do is create, let's put cards on the table so that you know what we're doing. We're creating objects, and then using raycasting, we're going to put them in the scene, place them in the scene. But first, we need the object to create. So I'm going to hide environment just so that I don't have to deal with it while I'm manipulating my object. And create a new empty game object, and I'm going to call this sheep. Or like, if you don't like sheep, goat, whatever you want to do. This is where I offer you some creative freedom. You're welcome to create whatever sort of asset that you want. I'm going to create a very simple sheep by making sure my sheep position is 0, 0, 0. Right-clicking on this game object. So when I create a new asset by right-clicking on a current existing asset, it's going to create a child game object. So it's just going to structure this in this hierarchy. So I have my sphere. I'm not even going to bother naming these because this is just quick and dirty. I'm going to squish this down a little bit, duplicate it. That's a head, which needs to be scaled down. Rotate it a tad. And then give it some legs. With my sheep, I'll create a cylinder. What? Oh, that's the capsule collider. Scale it down to like 0.2. Move it into a general leg area. Okay, and go wild here, because we have very little time. So just be as expressive as possible. Unlike me. How what? It doesn't, at this point it doesn't super matter because we're just creating a random object, but like I said earlier, I could create I could create a cube here, which I know is a 1 by 1 by 1 cube, or rather, yeah, 1 by 1 by 1 cube. So this sheep is like 1 meter tall. Is that normal for sheep? I don't know. How tall is a sheep? Average height 3 to 4.5 feet. Height. Anyway, okay. How are people with their sheep? Does anyone still need a moment? Great. So this is a kind of important step. If we turn back on our environment, my sheep is in the middle of a cube, which sucks. So I'm just going to move that cube out of the way. This is really important because right now the origin of my sheep, so this parent game object, is in the center of the floor, which isn't super cool because we want to create a sheep standing on stuff, not like emerging in the middle of stuff. So one way to get around this is without selecting the parent object. So without selecting this sheep object, select all of the children and move them up. Right? So now when I click sheep, the center or the pivot point of this object is still right on the ground, which is great. So if I was to rotate this sheep, for example, it would be rotating around its legs, which is kind of how we expect a sheep to rotate, you know? Classic sheep. And the section that we did, that we skipped on camera, will cover a little bit more about origins and parenting. So if any of this confuses you, just revisit that section and hopefully that will provide some clarification. So without selecting, the pivot point is essentially the parent object. So the way that you change it, or rather the way that you change the placement of all the things inside, is don't select the parent, select everything inside, all of the children, and move them around. That way the parent stays in its place, but the children all move around. Does that make sense? Yeah. This way when we create a new sheep, the center point of the sheep is going to be like the legs. So now what I'm going to do is a new step. I have a folder in my assets called prefabs, but that's not super necessary. And I already have a sheep, so I'm going to rename that sheep to old. You don't have a sheep, so don't do that. But I would suggest creating a folder called prefabs. And now we can drag the whole sheep into prefabs in a process called prefabbing. This is kind of outside of the scope of this workshop, so I'm not going to cover this too in depth, but a prefab is creating a version of an object that you can then, a template kind of, so you can create multiple versions of the same thing. So now that I have a template of a sheep, I can, this is very important, in my hierarchy delete the sheep, but not in my project. If I delete sheep in my project, it will delete all of my sheep ever, and I don't want to do that. So keep the prefab sheep alive, but kill the hierarchy sheep, because I don't need that anymore. Cool. So now I'm going to create an empty game object. So this is an interesting conundrum that I often deal with. Is like, what's going to handle my app? What's going to handle my interaction or the things that I'm doing? Sometimes you can put these scripts on your main camera, sometimes you put them on your environment, but I'm going to create a new empty game object. And the sole purpose of this is to contain the scripts that I need to run. So I'm going to call this the sheep placement handler. And I get very explicit about the way that I name things. So if something's going to handle all the sheep placements, I will call it the handler of that thing. If something creates new things, I'll call it a factory. There's different terms for these things. But in this case, it's a handler because it's handling. I use the term handler as a kind of general catch-all. It doesn't actually matter where this is in the scene because it doesn't have any attached mesh components. However, just to be on the safe side, I'm going to reset its transform to 0, 0, 0. Then I'm going to add a component, and my component, what do I want my component to do? Right, yeah, so that's but like broader than that. What is it doing? You kind of mentioned it, like place the sheep, right? So I'm going to call this the sheep placer. Right? And you could be a little bit more creative in your naming if you wanted to. I could also be more explicit by saying sheep placer by Raycasting, something like that. You know, like be explicit in your naming. It'll save you lots of time later. Great, and I'll open that up, and we have a new empty class called sheep placer by Raycasting. How are people doing? Any confusion? Fantastic. Okay, I'm gonna steam ahead then. Oh, okay, is it time to introduce this? Yes, it is. Many people might have seen the term public something, public float, public this, public that. I prefer to use serialized field. For the same, essentially, people use public a lot to expose elements to the editor. So if I say public float my number, then my number is now something in the editor that after this updates and updates, I can now choose what my number is in the editor. However, public has another function which is exposing variables to other scripts, which is not necessarily what I'm intending to do right now. So to be very specific in my intention, I don't want this variable to be public, but I do want to expose it to the editor. The way that we can do that is by using this serialized field keyword in square brackets before. And it does the same thing. It exposes this parameter, sorry, this variable to the editor. But this variable is not public, so it can't be modified by other scripts. It's capital S, aerialize with a Z, capital F field. Okay, but what I'm trying to expose is not the float my number, because that's meaningless. What I want is to give it the prefab, the sheep that we just created. And all prefabs are game objects. So if you have a prefab that you want to instantiate in your scene, it's a game object, and I'm going to call this sheep template. Right? Or you could call it sheep prefab. That's up to your whatever your naming conventions you have. I wouldn't call it sheep because that's kind of generic, and you might have sheep later on in your script. So now, in my editor, I have a sheep template field, which has none, and it tells you that it's expecting a game object. So what you can do is go into your prefabs and drag the sheep that you just made into sheep template. Okay. So once you've done that, this script now has access to this sheep template. And since we have 10 minutes left, I'll kind of rush through the introduction to this. But to put the sheep from a prefab into your scene is a process called instantiation. And the way that that looks is game object sheep, or I'm going to call this sheep clone actually, equals, and then we use instantiate, and we tell it what we're instantiating, so the sheep template. Don't worry about following this just yet because we'll get into the raycasting in a second. And then we give it a position and a rotation. So in our case, position, we could say vector 3.0, and then rotation is this new word quaternion.identity. We can talk about quaternions if you want to. For now, all you need to know is quaternion.identity means no rotation. So there's no additional rotation on this. Does it? Fantastic. He shook his head. Yes, quaternions, maybe I'll do a workshop on them if you want. Oh, and this is an update. I definitely don't want this in update. I want this in start. So what this script is going to do is it's going to take this template, or it's going to create a new game object called sheep clone, and put that object in my scene. And the object will be stamped out of the sheep template prefab. It will be at position 0, 0, and it will have no rotation on it. There we go. There's my sheep. Cool. But I don't want to add my sheep clone at 0, 0. I want to add it where I click, right? Using Raycasting. So remember earlier how I said in this Unity documentation there's this, where is it further down? Screen point to camera.main.screen point to ray. This is a really useful function which is essentially taking all of the difficulty of creating rays away from us and saying point a ray from the camera into the scene. Like, that's all you do. And when you give it a mouse position, it's pointing a ray from your camera to where the mouse is. And it's doing all of that calculation of like 2D canvas to 3D. And this is just a way of saying click on stuff in your screen, in your scene, which is fantastic. So how are people following? This last 10 minutes is going to be a bit of a rush, and I apologize for that. But I don't know. Is anyone sad about that? Cool. So we will quickly write a function, and I'm not going to explain as much of this function as I was before. That's going to say if input dot get mouse button down 0. So 0 is the left click mouse button. When on the frame that it detects this mouse button gets pressed, do something. What am I going to do? What I'm going to do is handle Raycast. This is a style of programming I like to call optimistic programming. We create the name of the function before we build that function. But we create the name of the function to imply what the function is going to do. The magic that I just did, if you have a function that doesn't exist, I guess on Mac it would be command full stop, but on Windows it's control full stop. It gives you an option to like generate this function. So if I hit enter, I now have created a new function with that name.
What is full stop?
It's just one of the key. What do you mean? Oh, period. Sorry.
Okay.
Period. Sorry, not full stop. Full stop. Period. Whatever you want to call it. So this is great because you can start programming like, you know, oh, I've got that, and then I've got this. I'm going to create a new function here, and that function, and then command full stop, and you feel like a real programmer because you're building out your code really, really quickly. But what I'm doing is I'm saying, in my handle Raycast, I'm going to create a new ray, just like we did before, but instead of giving it actual vectors, I'm going to ask it to handle all the vectors for me. So Unity handles all these vectors because this is such a used function that we can say camera.main. So camera.main just finds the main camera of your scene. This can get complicated if you have multiple cameras, but we don't have multiple cameras. So it's just going to find the camera that we're using. And every single camera component has this script, it has this option, this method, which is screen point to ray. And if we use our, screen point to ray, that kind of implies what it's going to be doing, but we have to give it one more thing. So take a point on the screen and cast a ray from the camera through that point into your scene. This can be any point, so you could have like a little person floating around and raycasting all the stuff behind it. But what we're going to do is give it the input dot mouse position. Okay. So this is a little bit of a clunky function. Get the main camera, call the screen point to ray function of that, and give it the current mouse position. Input.mouse position is a vector that is kind of like mouse X and mouse Y in P5. So now we've got a ray that's pointing into our scene. Cool, and it's figured out what the position and what the rotation of that direction of that ray needs to do. So what we can do is say if physics dot raycast ray oh, and Aaron, you're right. If I wanted to be explicit about this, I could call this camera ray, for example, or mouse ray or something. I'm going to call this mouse ray. It sounds like a cool band, not a cool band name, terrible band name. And then we need to give it some information, right? Some object to store the hit information. So what am I missing here? 100%. Creating a new Raycast hit object. Oops, Raycast hit. And calling it mouse hit. So we give it a ray and we give it a mouse hit. And there's something that I need to add here. Does anyone remember what it is? Out. That out keyword. One thing I would say is don't panic about like memorizing this. Don't spend your brain power memorizing exactly what has to go where, because the documentation tells you. So just get a general sense of the main components of this. So sending a ray and then getting the information back. Okay. Any confusions at this point? Fantastic. So the final thing is, do you remember how do we get the location of the hit point? I mean, Collider is great, GameObject is great, but like hit points. Yeah, that's what I'm looking for. So the position of the hit is so used that they named it something really, really small and concise so that we can use it all the time. So we don't even need to rename it as a new variable. All we need to do is say, this is the point where we can create our sheet, because we have hit.point, right? So let's create a new sheet by using that line that we were writing earlier, which goes new game, well, not new, but game object sheep clone is equal to, does anyone remember what comes next? Thank you. Instantiate. Right, okay, so this is sheep template, but do we write vector 3.0 here? Exactly. Cool. So here we can just write the hit point or the mouse hit dot point. And then there are ways to deal with quaternions, but we're not going to deal with them. So we're just going to say, at the moment, give it no rotation, which is by saying quaternion.identity. Okay. Who can anticipate what's going to happen when I run this scene? Any thoughts? Let's just run through the code. So we create an array that points from our camera into the scene, or from our mouse into the scene. Then we say, hey, cast a ray from here. Do we hit anything? If so, instantiate a game object at that position. Yeah, so we're putting, I mean, this is really close to where we need to be. We're putting sheep in our scene whenever we click, right? But we've got this problem of they're all facing, like, they're all kind of standing straight up, which maybe these are like mountain goats. So maybe they can do that. But my sheep are kind of drunk and they're going to fall over a little bit. So in our last negative 1 minute, this is like one line of code, but it opens up a whole floodgate of like new concepts. So I'll just give it to you and let you sit in the confusion. Cast your mind back to the beginning lecture on vectors. The normal. Fantastic. And you know how useful normals are? They're so useful that they give it to us in the hit object. So we can say mouse hit dot normal, and that basically, where the ray hit the object, it takes the surface normal of that place, which is perpendicular, and gives it back to us. So what I want to do, and this I only know because I've experimented and tried it a lot, is we've got sheep clone, and currently it's standing straight up. But we can access the transform of that sheep clone. And we can take that up vector that we started playing with, like transform forward, right, up, and we can set it to the normal. So we're saying, you, sheep, up is no longer this way. Up is now this way. And when we do that, once we click on planes, the sheep stick to the planes as if they were kind of super glued there. So does anyone have any questions? Because there's one final thing which makes this all worth it.
Gravity.
Beyond that, so how would you get gravity to apply to a game object? That's the complicated way of doing it. Not incorrect, just complicated. In our, a couple of people have shouted this out. So in our sheep component, which currently isn't in our scene, right, because we deleted it. But in our sheep prefab, we can add a component of type rigid body. So what's beautiful about the rigid body and the way that it works in Unity is rigid body seeks, where is it? Rigid body applies to both the parent object and all its children. So it looks for colliders on everything under this object. So once we apply it, all of the colliders that we added to sheep are going to come into play, which means that without doing any more code, we just added a rigid body to sheep. Once we play, our sheep kind of start falling down. And wonderfully, that ends our